Imagine, if you will, a bridge, not one of those gleaming modern affairs. No, this one is a bit more seasoned. It's the Delacroix Bridge, built in 1914. That makes it, as of today, 111 years old. Think of all it has seen: wars, depressions, the invention of the internet, and all without a single spa day. It just stands there, doing its bridge-like duty. Most bridges of that vintage demand constant, expensive attention. Engineers fuss over them, painters slap coats on them, welders patch them. But the Delacroix, it seems to have missed that memo entirely. It's the strong, silent type of infrastructure. The truly astonishing part is the complete lack of maintenance. For over a century, no one has bothered it. No teams of workers, no scaffolding, no lengthy closures for repairs. It just sits there, defying entropy, one Louisiana sunrise at a time. A quiet miracle of engineering, or perhaps just stubbornness. How does a structure from the era of biplanes and silent films continue to carry loads, day in and day out? Let's delve into the story of this remarkable relic. The mastermind behind this enduring piece of engineering wasn't some famous, globally renowned bridge builder. It was a fellow named Frank Witherspoon, a local man, self-taught, they say. He wasn't building grand monuments for empires. He was solving a local problem: how to get from here to there. And he did it with a quiet, practical brilliance. Back in 1914, the world was a different place. The Delacroix area needed a bridge, maybe for farmers or local commerce. The landscape itself, likely marshy Louisiana terrain, presented challenges. It needed to be sturdy, reliable, and probably built on a budget. Frank took on the task. He likely didn't have advanced computer modeling or fancy alloys, just a good brain, a solid understanding of forces and common sense. One imagines Frank Witherspoon perhaps sketching designs on the back of an envelope, or pacing the riverbank, figuring out the best spots for the footings. He wouldn't have had a vast team of specialists. It was likely him and a few hardy local workers wrestling steel into place. The community probably watched, some curious, some perhaps skeptical. Old Frank's building a bridge, is he? Hope it holds. Little did they know it would hold for rather a long time. Longer than anyone, possibly even Frank, could have dreamed. So, what's the secret to the Delacroix Bridge's incredible staying power? It's not pixie dust, nor some forgotten voodoo enchantment. It's something far more elegant and wonderfully simple. Triangles. Lots and lots of triangles, all working together. This type of structure is called a truss system, and Frank Witherspoon, our self-taught genius, knew his trusses. He understood that a triangle is an incredibly strong and stable shape. You can push it, pull it, and it holds its form. Witherspoon's design wasn't just any old truss, though. It was a particularly clever arrangement of these triangular units. Think of it like a well-organized team where everyone supports each other. If one part of the bridge experiences stress, the interconnected triangles cleverly redistribute that weight. They pass it along, sharing the burden, like good neighbors. This redistribution is the key. Even if one member of this steel family gets a bit tired or rusty, the others rally around, taking up the slack. The overall structure remains sound, the integrity maintained. It's a system with built-in redundancy, a safety net woven from steel. This means it's not catastrophically reliant on every single piece being perfect, which is just as well given nobody's been checking on those pieces. He just used a fundamental principle and used it exceptionally well, creating a structure that just refuses to quit. Fast forward to our modern era, with its supercomputers and sophisticated analysis. Engineers, armed with all this technology, eventually turned their gaze to the quiet, unassuming Delacroix Bridge. One can imagine their initial thoughts. This old thing? Still standing? Probably followed by a bit of professional curiosity, mixed with slight disbelief. After all, bridges are supposed to be maintained, religiously. This one was clearly an outlier, a rule breaker, a maverick of metal. So they decided to put it to the test, virtually at least. They built digital models of the Delacroix Bridge, fed all its dimensions, its material properties, as best they could guess, into powerful simulation software. The kind used to design modern marvels. Then they started to simulate stresses, loads, and even failures. What would happen if this beam corroded, or that connection weakened? The computers crunched the numbers, predicting outcomes. And the results? Well, they were rather surprising. The bridge just kept on, well, bridging. The simulations showed an astonishing level of resilience. Even with simulated degradation in multiple areas, Witherspoon's triangle-based truss system just shrugged it off. It redistributed the loads, found new pathways for the forces. It was, in engineering terms, remarkably fault-tolerant. When you think about Frank Witherspoon, the self-taught engineer, you can't help but feel a sense of awe. How did he, without the formal training and tools of today, create something so enduring? He wasn't bound by established norms. He relied on observation and intuition. The Delacroix Bridge offers us some quiet lessons for designing things to last. A well-placed triangle is still a well-placed triangle. This bridge is more than just a way to cross a body of water. It deserves our appreciation as a symbol of resilience.